Hope we're doing it good, everybody today out there in the internet land. Today's Google Doodle is the Wackle Dackle. We're gonna make that stay. That's a Wackle Dackle. If you care, you know. Just showing you there. Another term for a bobblehead. Just showing everybody at home. So if you hit it, that's nice. That would not be great. All right, so we're section 2.4, writing equations of lines. Like I was talking about just a second ago, today's lesson is where we start to create the equation. You know, yesterday's lesson is where we were graphing these functions, and now we're starting to create the equations based on all different types of information. We know slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So that's one of the key pieces of information here, or one of the ways to write the equation. We have two important pieces of information in that equation: the slope and the y-intercept. Remember that whenever you write an equation, you have to have a y and an x, unless it's a vertical or horizontal line, then, right? Obviously, it would just be a y equals or an x if it was a vertical or horizontal. But anytime you write an equation, if you go to put your answer on an answer blank, you should have a y and an x, as long as it's not vertical or horizontal. The m and the b is what needs to be replaced with actual values. So let's take a look here. Write the equation of the graph line in slope-intercept form. I'm going to be telling you to write it in a particular form. You know, more often than not, we're not going to be working with point-slope form. It has its uses, but you know, usually I'll ask you to write things in slope-intercept form, which is that y equals mx plus b form. Okay, so to write it into slope-intercept form, I need to identify what the slope is and identify what the y-intercept is. The easier part to pick out is the y-intercept. What is the y-intercept in this case? 1. Crosses right here at 1. Again, y-intercept, not x-intercept. Please don't say 1.2 or something like that. This is the y-intercept, not the x-intercept. Now we define where our slope is by just taking the rise over the run. So how much is this sloping? So I go up 2, 3 over 1, 2, 3, 4. Rise 3, left 4. Right? Rise 3, left 4. Up 1, 2, 3. Oh wait. Did I go wrong? Oh no, sorry. 1, 2, 3. 1, 2, 3, 4. Rise 3, run to the left 4. I'm stating that my slope is negative, so maybe go back and say, okay, is that truly correct? Is it making an n? Yes, it is. I know this slope is indeed negative. Do that check for yourself. Now we can go in and say, okay, I've got my m, I've got my b. Y is equal to negative 3/4 x plus 1. That's the easiest way to write an equation, is if I give you the graph and I ask you to write it in slope-intercept form. Identify what the slope is, identify what the y-intercept is, and then just plug in what you know. Okay? All right, so what if, you know, I'm giving you just 2 points? Well, you're going to need to find the slope. I think we can all agree that with that last example, the slope was a very important piece. The slope is always going to be a very important piece. Remember that the slope formula is y2 minus y1 over x2 minus x1. Some people say rise over run. Some people say change in y divided by change in x. You know, I talked about it yesterday, being a consistent change in x is a consistent change in y, constant change in x is a constant change in y. If I was a science type person, I might write this. What are those triangles? What are those triangles? What does that mean? Delta, right, delta. The Greek letter delta meaning change in, okay, change in. Delta x over delta y. Okay, so basically all I'm saying is you find the difference between the x values, difference in the y values divided by the difference in the x values. How much is y changing versus how much is x changing? It's a ratio, right? It's a ratio. And every ratio in my line is proportional to one another because the slope will never change. So let's find the slope between these two coordinates, -1, 1 and 2, -5. Okay, so I'm going to write out the slope formula. M is equal to y2 minus y1 over x2 minus x1. I think it's really beneficial, and you'll see me do this a lot. Every time you learn a new formula and you're working with it, write it out algebraically every single time. Write out the formula every single time, because that's the best way to memorize it. So I'm going to take y2 minus y1. Well, it doesn't really matter which one we take, x1, y1, x2, y2, as long as you keep them in order. So if I take this second point as my x2, y2, well, then I just have to keep making sure that my first point is x1, y1. All right, so y2, negative 5, minus the other y value, 1, over 2, that's 2, minus a negative 1. Be careful with the minus and negatives, folks. Be careful with the minus and negatives. Again, that was negative 5 minus 1 over 2 minus negative 1. And when we evaluate, we get negative 6. And then 2 plus 1 is 3. So my slope is negative 2. Slope is negative 2. Not positive 2. Not positive, not negative 6. Positive, or negative 2. Negative 2. I could also write that as negative 2 over 1. That would be fine as well. Okay, you can write the whole number as a fraction. That would be the same thing. Any questions about that? Just be careful when you're doing your operations again. All right, so yesterday we talked about given a table, determine if it's linear. And we said, okay, well, a constant change in y should correspond to a constant change in x. And we talked about how that relates to slope. The same thing is true here. I can identify what the slope is by looking at that constant change. I'm going up 4, up 4, up 4, down, up 3, up 3, up 3. Just be careful. Is my slope 4/3 or 3/4? 3/4, right. It's always change in y over change in x. So my slope is 3/4. Okay. Now, did I need to do all of those values in there? No, I could really just find the change in y divided by the change in x between two sets of points. Right? Now, I only need one of these two things to identify what the slope is. Because if I'm assuming that it's a line, I don't have to do that check. Right? It says find the slope of the line. Okay, well, then I can assume that the slope stays consistent throughout. All right, write the equation of a line in slope-intercept form through point 1, 3, slope negative 5. Okay, so here's where it starts to get a little bit more fun, a little bit more difficult. I'm given the slope though, which is awesome because that's one of the harder pieces to find. I'm given the slope to be negative 5 and the point to be 1, 3. The slope to be negative 5 and the point to be 1, 3. Now, when I do that, I can either do this one of two ways. There's this one method called solve for b, or I could use point slope. Now, did you guys use point slope much in geometry last year? Okay, I'll show that method. Then some of you guys probably won't like it just because point slope is harder to remember. But I want to show you that method because it does have its uses. So if I was truly trying to find, let's take a look at our two methods here. If I was truly trying to find y equals mx plus b, what's the other piece of information that I need? The y-intercept, right? I need my b value. That's the only other piece. I've got my slope. Sweet. I've got my slope. I just don't have my b value. So I need to solve for b. That's where I say this method I call the solve for b method. The nice thing is I'm given a coordinate. Now, be careful. Is my b value 3? No. My b value is not 3. If it was 3, this would be 0, 3. This is 1, 3. This is not my y-intercept here. But I can use that coordinate to find what my slope is going to be. Okay, I've got this equation y equals mx plus b. I have an x and y value and an m value. If I plug all of this information into this equation, I can solve for what b should be. Y value is 3. The m value is negative 5. The x value is 1. And then plus b. Does everybody see what I did there? All I did was use my coordinate as my x and y value. I used my slope as my m, my given slope. And now I can just solve for b. 3 is equal to negative 5 plus b. Add the 5 to both sides. I get 8 as my b value. And now I'm given enough information to write my equation. I can say that y is equal to negative 5x plus 8. Again, that's the solve for b method. Solve for b. I want to show you the point slope method. Point slope. Again, point slope maybe, I don't know, it might not be your cup of tea just because you don't know what point slope form is. Point slope form is y minus y1 is equal to m times x minus x1. Okay. True. Hold on a second. Yeah, sorry. Ooh, had a blank out moment there. Okay, so y minus y1 is equal to m times x minus x1, or x minus x1, yeah. So what do I see here? Well, I see that I've got an x and a y value, but then I've got this x1, y1. That x1, y1 could be any point. You know how in slope-intercept form, I needed my b value? I needed a very specific coordinate. I needed one that was 0, a number. With point slope form, I could use any number. I could use any coordinate in that slope. So I would say this. Y minus 3 is equal to m x minus 1. I use the coordinate 1, 3 and the slope of -5. And now, to put it into slope-intercept form, we did this yesterday, just solve for y. Distribute in, y minus 3 is equal to -5x plus 5. Add the 3 over, -5x plus 8. So if you know point slope form, like I gotta be honest, I use point slope form more than the solve for b method. Because point slope form is just stuck in my head. I just know that formula. So if you know that formula, you could use any coordinate to figure out what your equation is. You don't need your b value. Okay. It works itself out in the end. You can identify it in the end. If you're wondering where point slope comes from, think about your original slope formula. Y minus y, we'll say y minus y1 over x minus x1. I could have put the 2's here, but you'll see why here in a second. How do I get this whole chunk over to the other side? If I'm dividing by x minus x1, what undoes division? Multiplication. So really, all I'm doing is multiplying x times x, x minus x1 over to m. And look, that's what gives you point slope form. That's where this comes from. Okay? That's how you derive it there. M times x minus x1 is equal to y minus y1. Yeah, kind of like just a manipulated slope formula. All right, so that's if you're given a slope and any point. What happens if you're not even given the slope at all? Okay, what happens if you're not even given the slope at all? Well, if I'm given 2 coordinates, I have the ability to solve for my slope. Okay, as long as you're given 2 coordinates, you have the ability to solve for your slope. So let's do that. The slope formula again is y2 minus y1 over x2 minus x1. So that gives me 5 plus 3. I'm saying plus because it's minus a -3 over 2 plus 2. And again, I'm saying plus because it's minus a -2. So it's 8 over 4, which is 2. My slope is 2. Now, at this point, I can choose to do either method with either point. Okay? I can choose to do point slope or solve for b with -2, -3, or I could choose to do point slope or solve for b with 2, 5. I like to stay positive, so let's use 2, 5. I'm going to show both methods again, because I think it's beneficial to show both. So I've got m equals 2. And I'm using 0.2, 5. Could I have done this with -2, -5? Of course I could. I'm just going to use 2, 5 just because those are both positive. So again, we've got y equals mx plus b. And I'm going to solve for b. Y is 5, m is 2, x is 2, and b is our unknown. 2 times 2 is 4. So therefore, b is 1 when I subtract the 4 over to the other side. So my equation is y equals 2x plus 1. Using my point slope method, I would say, again, y minus y1 is equal to m times x minus x1. 5, oops, sorry. Y minus 5 is equal to 2x minus 2. Right, the coordinate 2 comma 5 with a slope of 2. Distribute the 2. Add the 5. I get the same answer. Again, it's your choice from here on out. I don't care what you do. Solve for b, point slope, find the one that works for you, and do that. Okay. Now, so here's what I've given you. Now I've given you a coordinate and a slope. I've given you 2 coordinates. And now what we're going to do is I'm going to give you a certain set of lines. I'm going to give you either parallel or perpendicular lines. Okay. What do we know about the slopes of parallel lines? They're congruent or equal, right? If you think about 2 parallel lines, they will never touch, right? So if one is consistently going up this way, the other one must be consistently going up in the same direction with the same magnitude, right? They must have an identical slope. Parallel lines have the same slope as long as the slope is defined. Parallel lines will always have the same slope as long as the slope is defined. When is the slope undefined? When is the slope undefined? In a vertical line. In a vertical line. And wouldn't we all agree that any 2 vertical lines are going to be parallel to one another? So this is the only caveat there. That's the only one that's like, well, it's as long as the slope is defined. But if it's not defined, it's vertical anyway, so those are parallel. Horizontal lines, the slope is defined, it's just at 0, right? And we could say that any 2 slopes with 0 are going to be horizontal lines. They would always be parallel as well. So take a look at the example that we're given down here. Y equals 2x plus 1, y equals 2x minus 3. The only difference is the y-intercepts. If you take 2 lines in slope-intercept form, the only difference between the 2 lines, the only difference between the 2 equations will be the y-intercept. Now, does anybody remember the rule for perpendicular lines? Opposite reciprocal. Yeah, opposite reciprocal. Perpendicular lines have slopes that are opposite reciprocals of one another. It's funny. The book says, I see the 2/3 on it. Yeah. The book says, as long as the slope's product is -1. Like, really? Just say opposite reciprocal. Because if you take 2 opposite reciprocals, one positive, one negative, obviously they come out negative. And if you took 2 reciprocals and multiplied them to one another, they would come out to be 1. Because that's the idea of the multiplicative inverse, right? You take 2 things that are reciprocals or multiplicative inverses, you multiply them, you get the identity, 1. But we can just remember the rule, perpendicular lines have opposite reciprocal slopes. So if one is -3/2, the other one is positive 2/3. The $10 word for perpendicular is orthogonal. 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 You ever hear that before? Orthogonal. I think I'm spelling that right. Orthogonal. I gotta look that up. Orthogonal? Is that how we spell that? Orthogonal? Oh, I did spell it wrong. Orthogonal. That was close. But that's just the a really fancy way to say perpendicular. But anyway, opposite reciprocal slopes. Opposite reciprocal slopes. Write the equation of the line in slope-intercept form that is parallel to 1.8x plus 3 and runs through 0.5, 2. All right, so if it's parallel to that line, What's the only thing that I care about from that equation? The slope. Do I care that it runs through the y-intercept of 3? Nah. It's like the y, it's parallel to y is equal to 1.8x plus I don't care. I don't care about that plus 3. Sorry, buddy. Sorry. So I know that the slope is 1.8, and then it goes through 0.5, comma 2. I don't love that they give us a slope that's a decimal, but I'll make do. All right, so let's do the, what do you guys like more? You like the solve for b or the point slope? Who likes the solve for b? Who likes the point slope? Okay, there's some of you out there. It was more solve for b, so I'm going to do solve for b. Sorry for a second. So y equals mx plus b. Here's 2 is equal to 1.8 times 5 plus b. Okay, 1.8 times 5, that's 5 plus 9, I think. 9 plus b. Somebody check me on that. 1.8, is it 9? Okay. I subtract the 9 over to the other side, I get negative 7 is b. So my equation is y is equal to 1.8x minus 7. Again, the only difference between the problems that we were doing and that we are doing is that I'm now just saying, okay, it's parallel to this line, so this is the only piece of information that I care about. Once I get to that point, knowing that the slopes are the same, it reverts back to the ones that we've already done. I'm given a slope and the point, create your line from there. So we did a parallel one, let's look at a perpendicular one. Okay, so it's perpendicular to negative 3 halves x minus 1. Negative 3 halves x minus 1. So I like to think about it this way. My old slope is going to be negative 3 halves. So what is my new slope going to be? Positive 2/3, right? Positive 2/3. And I know it's going to run through 0.9, comma, negative 2. All right, so we say y equals mx plus b. Got to solve for my b value. Negative 2 is equal to m, 2/3, x, which is 9, plus b. So 2/3 of 9 is 6. Subtract the 6, I get negative 8. Y is equal to 2/3 x minus 8. For you point slope people out there, y plus 2, yeah, plus because this is minus a negative, is equal to 2/3 x minus 9. And then you say y plus 2 is equal to 2/3 x minus 6. We subtract the 2, 2/3 x minus 8. Let's stop the video. All right, there we have it for today. Orthogonal. Orthogonal. That's a fun word.